Hello everyone. In this video we're going to be integrating a very interesting function, 1 over the cube root of 1 plus x cubed. This problem is from a magazine called Crux Mathematicorum. I hope I pronounced it correctly. A Canadian math magazine, which is full of beautiful problems. And it's just one of them. So to be able to solve this problem, we're going to use substitution, but things are going to get real messy, so bear with me while I give you the method. So first, and there's more than one way to do it, but because of the heavy load, I'm just going to talk about a single method here. I hope you don't mind, and if you can figure out another way to do it, let us know in the comment section down below. And if you like complex numbers, go ahead and check out aplusbi, which is my other channel. I also have a channel that focuses on shorts. Great, now let's see how we can solve an integral like this. So I'm going to go ahead and make a really weird substitution. And guess what it's going to be? It's not this one, or it's not 1 over that one. It's going to be completely different. And you're going to know why that works in a little bit, okay? So let's start with calling or setting u equal to x divided by the cube root of 1 plus x cubed. Again, it's going to become clear in a little bit, okay? Now, after you name this u, your goal is to basically find out what the x is going to be in terms of u, right? So you do need x by itself. So let's go ahead and cube both sides. And from here, it's probably clear that solving for x shouldn't be too hard, right? To kind of give you a little break there, I'm just going to give you x cubed in terms of u cubed. It's just kind of like finding the inverse function as well, if you're familiar with functions. But you can easily pull x cubed from here. Cross multiply, put x cubed on the same side, and then factor, okay? And this is x cubed, but we can kind of write it slightly differently. But before that, let's go ahead and cube root both sides first. So when you cube root this, you're going to get u. And when you cube root this, you're going to get 1 minus u cubed, but it's the cube root of that. So far, so good. Hopefully you're following. Now, I'm going to go ahead and write the denominator as 1 minus u cubed to the power 1/3, because the cube root means something to the power 1/3, right? And this is going to be helpful for me to write x in terms of u. And since this is in the denominator, let's go ahead and use a negative exponent, because what I'm about to do is differentiating both sides to find the x. And of course, you have to include the du, right? So if you differentiate both sides from product property, you're going to get something really messy. Can I just give you the answer without going into the specifics? Oh, anyway, let's just work it out. So you're going to differentiate it, the derivative of u, which is 1, multiply by the second expression. So it's going to look like this, plus the derivative of the second piece, which is negative 1/3, multiplied by 1 minus u cubed. They're going to have to reduce the power by 1, which is going to give you negative 4/3, and then multiply by the derivative of the inside, which is by the chain rule, negative 3u squared. And of course, this is just the derivative of the second function. Then now you're going to multiply this by the first function, which is u. And of course, the whole thing have to multiply by du, because x is a function of u, so dx is going to be a function of du. I hope that makes sense. And again, this is very messy, but I just wanted to show you this intermediate step, so we're not jumping around. Now, if you simplify this a little bit, you're going to get something like this. 1 over, because something is going to simplify, right? Some stuff. You're going to get 1 over cube root of 1 minus u cubed plus u cubed divided by the cube root of 1 minus u cubed to the 4th power. And this just comes from the fact that, you know, we have a negative 4/3 here. You can just write it in the denominator. But guess what? We can kind of simplify things a little bit more here, because now you can make a common denominator. So you have to multiply by the cube root of 1 minus u cubed, right? And then just, you know, plug it in, and it should just work, right? And by the way, I said cube root of 1 minus u cubed to the 3rd power. That's what I meant. Because if you think about it, this is cube root of 1 minus u cubed to the 3rd multiplied by cube root of 1 minus u cubed. And this is 1 minus u. So all you need is multiply by 1 minus u to make a common denominator. So it's going to look like this. 1 minus u, right, will be multiplied there. I'm sorry, 1 minus u cubed. That's what I meant. And then plus u cubed. And then the common denominator was just going to be the cube root of 1 minus u cubed to the 4th power. And of course, there's a du as well. Now, these two cancel out, leaving us with something real simple. That's why choosing the u that way was a good idea. But how would you know, right? Again, it's just experimenting with different things. Now, let's go ahead and go back to the original. And what did we have? We had this, right? Oops. And now I'm going to make all the replacements. First of all, this is dx. So you can go ahead and do that, which is going to be in the denominator, by the way. So you're going to get this. Sorry for my threes, they look messy. And divide by this. Now you got to remember what we called, right? So what is that going to be replaced with? Well, here's the thing. If you consider the fact that 1 plus x cubed, and let's go back here, x cubed was called this. Remember that. So I'm going to replace x cubed with that. 1 plus x cubed, which is u cubed over 1 minus u cubed. And if you make a common denominator, you get u cubed. Oops. 1 plus u. All right, sorry about that. 1 minus u cubed plus u cubed divided by 1 minus u cubed. U cubed is going to cancel out. You're going to end up with 1 over 1 minus u cubed. So 1 plus x cubed is equal to 1 over 1 minus u cubed. Isn't that nice? So now we do need to cube root this because we need this, right? So it's going to look like this when we cube root it. 1 over, it is equal to, actually not, yeah, 1 over the cube root of 1 minus u cubed. There you go. Okay. After simplifying this stuff, you're going to get something like this. Of course, there's a du as well, and we're integrating both sides now. So you're going to flip this, and you know it's going to be multiplied by 1 here. So you're going to get something like the cube root of 1 minus u cubed divided by 1 minus u cubed to the 4th power, which gives you a 1 minus u cubed in the denominator. I hope that makes sense. Did I make sense at all? So here's what I'm trying to say. This is going to go here. And we already had this in the denominator, right? And now these two things, you can just write them underneath the same cube root. And then from here, because you have the 4th power, you can simplify this. One of these will be gone, and this will be a cube root or cube. And with the cube root, it's just going to look like this at the end. This is why our substitution works. That's why it's so powerful, because it turns it into something like this. And that's actually very, very nice, don't you think? Great. Now let's take it from here, because integrating this shouldn't be a big deal, right? How do you integrate that? I'm going to go ahead and do partial fractions. First of all, subtract. I mean, what am I talking about? I can't even, anyways, I can't even talk. Factor this using difference of 2 cubes. So it's going to look like this, right? And then you're going to go ahead and split it into 2 fractions by using partial fractions. So it's going to look like this, a over 1 minus u. And for this one, since it's not factorable, even if it was factorable, we could still do the same thing. But you're going to use a linear term in the numerator because the denominator is quadratic and there has to be a difference of 1 in degrees. Make sense? From here, a value is going to be 1/3, b is going to be 1/3, and c is going to be 1/3. I already gave you the magic formula because you're going to make a common denominator, and then you're just going to get the values of a, b, c. But those are the values of a, b, c. I think, wait a minute, c is supposed to be, I think, 2/3, right? Yeah. So our expression is going to turn into this then. After substituting the values of a, b, c, of course, I can factor out a 1/3 here, which is convenient. We'll have 1 over 1 minus u, and then u plus 2 divided by u squared plus u plus 1. Awesome. You see, this is a pretty easy integral. Look at this. This is just ln. Easy, right? What about the other one? Let's go ahead and work on the second piece, which is this one, which is kind of pretty interesting because you may not know how to do these. So here's how we can approach it. I'm going to go ahead and insert a 1/2 and a 2. So here's the idea. I want to make the numerator somewhat like the derivative of the denominator because of the degree difference. So, for example, what do you get if you differentiate this? The derivative of u squared plus u plus 1 is 2u, and if it's your birthday, happy birthday to you. Okay, I had to say that, sorry. We don't have a 2u though, we have a u. So, but what I can do is multiply by 2 and 1/2 at the same time so that they cancel out and leaves with 1, right? So 1/2 times 2, which is a common factor here, is going to give you the same thing. Make sense? Okay, now, this is good because we have 2u, but it's not 2u plus 1, but that can be fixed. So we can do the following. 1/2 multiplied by 2u plus 4 over, again, I'm just copying that because I'm going to show you how to split it up even more. So here's what we're going to do next. We're going to go ahead and write this as 2u plus 1 because remember, that's what we needed, right, from the derivative of this expression. But then, of course, you have a 3 left over. So now we're going to split it into 2 fractions, which is going to give us something super cool. Look at this. 2u plus 1 divided by u squared plus, u squared plus u plus 1, and then 3 over u squared plus u plus 1. Now you might be wondering, how am I going to factor this, right? Or how am I going to integrate this? Well, first of all, if you call this t, this is going to be t prime. In other words, you have the dt over t, which is ln again, right? Great. So that's easy. Let's call that easy. You can do that. And now we have this one. How do you integrate that? Easy. Again, forget about the 3 because that's not important. It's just a constant. How do you integrate this, right? That's what you need to know. To integrate this, we're going to use a hocus pocus, or what's known as, wait a minute, what was it called? Completing the square, yes. So we're going to write this as u squared plus u plus 1/4 plus 3/4. Now, why did I split up into 2 pieces like this? Because, and I can put the du here, this is a perfect square, and that's just perfect. Look at that. This is u plus 1/2 squared. How did I know that? Practice, a lot of practice. But this is basically arctangent. You know why? Because if you call this something else, I don't know, z, y, whatever, then you're going to get something like, let's just call it y. You're going to get something like y squared plus a squared. I'm going to call this a squared, which means a is equal to root 3 over 2. This is going to be like, and there's going to be some dy here, right? I think it's just going to be dy because they're the same pretty much. This is arctangent, right? So here's what you're going to get. Or you can do it this way too. You can call this y. So u plus 1/2 is y. But you know what I want to call y? I want to call y a times tangent theta. You know why? Because it's like y. A squared tangent squared plus tangent squared plus a squared is going to give you something nice. Let me show you here. So in other words, I'm going to call this a times tangent theta. Great. Now when I square both sides, I'm going to be getting u plus 1/2 squared, which is y, by the way. That's y, right? It's going to be 3 over 4 tangent squared theta. Great. So now you're going to replace y with that. And actually, this is y squared, not y, because this is y. So now you're going to get the following. And by the way, since this is y, du is the same as dy. Great. So I can now replace du with dy. Sorry, my work has been very messy so far. But here's what you're going to get from here. 3 over 4, tangent squared theta plus 3 over 4. Awesome. Now this is going to simplify a great deal. You know why? Because this is going to be 3 over 4 on the outside, but tangent squared theta plus 1, which is secant squared. I have the answer at the bottom. And this is going to be secant squared, and secant squared can be integrated. Oh, I forgot one thing here. I forgot to find dy in terms of theta. So I'm supposed to find d theta. Sorry about that. Change this to d theta. Something else is going to cancel out. Anyways, you can do it. The answer is going to be in terms of arctangent of u something. And then you kind of need to put it all together. Can you do that? Come on, I'm lazy, because this brings us to the end of this video, but I gotta show you the result from alpha at least, right? And ta-da-da-da, here's the result. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care. Don't forget to check out SyberMath and aplusbi, and bye-bye.